Dear students, welcome to the class. Today's class we are going to discuss about the topic half-wave dipole antenna. So presented by Manaka Devi, Assistant Professor at Department of Electronics and Communication Engineering, Hindustan College of Engineering and Technology. So these are all the contents of today's class. Dipole antenna, types of dipole antenna, half-wave dipole antenna. Dipole antenna. So what is a dipole antenna? A dipole antenna includes two conductive elements like wires and rods or wires, where the feeder at the center and the radiating sections of the antennas are either side. The metal wire's length is half of the highest wavelength, that is lambda by 2, within free space at the frequency of operation. Generally, the dipole antenna is fed at the center so as to transmit and receive RF energy. So this is the shape of the dipole antenna. Here the dipole, two wire or rods are directly connected to the transmission line. Here the transmission line may be a coaxial cable. Next, types of dipole antenna. Classification of dipole antenna is usually done on the basis of length of the electric dipole and its orientation. So dipole antennas are generally classified as half-wave dipole antenna, quarter-wave dipole antenna, folded dipole antenna, dual dipole antenna. First one is half-wave dipole antenna. It is an antenna having a length equal to half the wavelength at the frequency of operation. The second one, quarter wave dipole antenna. When the total length of the dipole is 1/4 of the wavelength at operating frequency, then it is known as quarter wave dipole. Next one is folded dipole antenna. A folded dipole antenna is formed by combining two half-wave dipole antennas in parallel orientation. Next, dual dipole antenna. Dual dipoles are the antennas that are formed by the combination of two dipoles and thus needs very large space. Next, half-wave dipole antenna. So a half-wave dipole antenna is an antenna constructed using a conductive tube or metallic element that has a length equal to the electrical half wavelength. The excitation to the half-wave dipole is provided at the center. So we can say that the feeding to the dipole is present at the quarter wavelength point. The external excitation to the antenna is provided at the center where the current is maximum and the voltage is minimum. Due to this, there is minimal impedance to the feeder by the antenna. Half-wave dipole antenna working. For the positive half of the voltage, when the amplitude is maximum, then the charge carriers inside the conductor gets attracted towards the positive applied potential. As against, when the negative half cycle of the sinusoidal signal is provided, then the charges present in the conductor experience repulsion. So every time with the change in polarity of the applied signal, there is a change in the direction of flow of electrons inside the conducting material. Hence, the back and forth movement of the electrons from an end to another cause it to get charged either positively or negatively. Thus, cumulative action of the electrons leads to generate current and the field is radiated from the half-wave dipole. Radiation pattern. As this antenna is a center feed, so the maximum current offers maximum radiation in the plane which is in perpendicular direction. The radiation pattern of half-wave dipole antenna is omnidirectional and is represented in the figure. So this is the antenna radiation pattern. So here the radiation pattern in maximum in the 0 degree and 180 degree. Next, advantages of half-wave dipole antenna. The antennas do not show sensitivity to input impedance. The length of the antenna is appropriate for the free space characteristics. with the operating frequency. The antenna is not bulky, so it is a very miniaturization. It is cost efficient. The input impedance of the dipole antenna properly matches with the impedance of the transmission line. So with this, we end up the session. Thank you, students.